Let's say we are asked to solve for x in the following problems. The first problem is that 2 to the exponent of x minus 3 multiplied by 16 is equal to 4 to the power of x. What do we do? Well, we try to make similar bases if we can attain similar bases so that we can apply the laws of exponents. Okay, so this is 2 to the exponent x minus 3, but we realize that 16 is 2 to the exponent 4. Why 16 2 to the exponent 4? Well, if you multiply 2 4 times over, what do you have? Pardon, that there should be another 2. So we're going to multiply it 4 times over and get a 16. Alright? So this here is another 2. This is 4 multiplied by 4, and it's 16. So we see that 2 multiplied 4 times over is a 16. This here is a 4, so that is the same as 2 squared. We just put 2 squared in the place of 4, and we take that to the exponent x. Okay, you can see that we are already having exponents that are the bases that are somewhat similar. On this side, we are now allowed to add exponents as the bases are the same. So we have 2 to the exponent x minus 3 plus 4. The 4 from here, since it is a positive exponent. And we are under multiplication, so when the bases are the same, we are allowed to add exponents. Okay, what do we do with this? When you have this scenario, you know that this is 2 to the exponent 2x. So you multiply the exponent, the inner exponent 2, by the outer exponent x. Now, we have something that looks interesting, but let's do the addition. So we have x plus 1 is equal to 2 to the exponent of 2x. But in order for this entire expression to be equal to that, since they are exponents of 2, then the exponents must themselves be equal. So we have that x plus 1 is equal to 2x. Okay, and you carry the x over to subtract it, so you have 2x subtract x, and 1 is still on the other side, so that is equal to 1. That means x is equal to 1. Okay, is that easy to see? Okay, let's move over to this one. Here you can see we already have a base of 5, so this is 5 to the exponent 2x plus 1. How can we make exponents of 5 this side? No, sorry, bases of 5, not exponents, but bases. So you see this base is already 5, and it's taken to the exponent of a half. Underneath we have 125. Does that make you think on a base of 5? With a little bit of thinking, you can see that 25 is what? 5 multiplied by 5. What is that? That is 25. What happens if you multiply 25 by 5? Then you get 125, okay? Because 25, 4 times over is 100, and then you get a fifth one, a fifth 5, a fifth 25, and that will give you 125, okay? So this is 5 to the exponent of 3, and at this stage we can carry this over, and we have 5 to the exponent of 3 multiplied by 5 to the exponent of 2x plus 1, and this is equals to 5 to the exponent of a half. Well, now the bases are the same, so we can add exponents. You see how it helps to try to make the expression such that the bases are the same. So this is 5 to the exponent 2x plus 1, and we add to that 3, which is that exponent there, and that will be the same as 5 to the exponent of a half, because exponent of a half is the square root. Okay, then we can do 5 to x plus 4, of course, 1 plus 3, that is 5 to the half. Just like we had in the last problem, we're gonna have that the exponent this side, this entire exponent, is equal to that exponent, since they're exponents of 5. So this is 2x plus 4 is equals to a half. And we can multiply both sides by 2, multiplied by 2. Then you take the 2, multiply the first term, and you get 4x. 2 again, multiplying the second term, and you get a positive 8. And this is equal to a half times 2, that is 1. Now you see that this is 4x is equal to minus 8 plus 1. So 4x is equal to minus 7. Then we divide both sides by 4. And we have that x is minus 7 divided by 4. Okay. Let's do another set of problems. Okay, this is what we have as a next set of problems. And we see again that expressing the bases as 2, like similar bases, helps to solve the problem. So what we have here is 2x minus 3 multiplied by 64. But what is 64? Well, 64 is 2 to the exponent of 6, okay? So you try to turn that such that it has a base of 2. And you realize that 2 to the exponent 6 is 64. What do we have there? We have a 4. I'd like to write it as 2 squared. That is the 4. And we take all that to the exponent x. What is an 8? It's 2 to the exponent of 3. Okay, now we realize that we have bases that are similar, and there are 2 bases. Okay, so 2 to the exponent of 3 comes that side, this side to the left hand side, multiplying 2 to the exponent x minus 3. Can we do the addition here already? Okay, plus 6, because we have similar bases here, we just added that onto that exponent. So we add 6 to x minus 3. And on the left hand side, what is remaining? On the right hand side, that is, well, when we have 2 squared all to the power of x, this is the same as 2 to the exponent 2x. Now we have 2 cubed multiplying 2 to the exponent x plus 3. That's what we get when we do minus 3 plus 6. So that is equal to 2x. We can simplify further by doing addition of exponents here, because the bases are the same, they're both 2, and we see that this is x plus 6, and it's equal to 2 to the exponent of 2x. Now we have returned to that form that we had previously, when we know that we can say x plus 6 is equal to 2x. Okay, and this means 2x minus x, we just carry this x over so that we group the x terms on one side, and as we move it over, it's going to be negative. What's remaining on the other side is a 6. So 2x subtract x is just x. So we have x is equal to 6. Okay. Now here's another expression, and we see basis of 3. Let's see what we can do with this here. Animal, and it's, let me just take that out, sorry. We see basis of 3, okay? This is x squared minus 1, and it's equal to, because 27 is 3 to the exponent 3, Okay, to be sure of that, just do 3 multiplied 3, that is a 9. We multiply 9 by 3 and you get 27. All that is taken to the exponent of negative x. Okay, and we have here underneath 3. Okay, now when this 3 comes over to multiply the side, we have 3 to the exponent 1 multiplied by 3. X squared minus 1 is equal to 3 to the exponent minus 3x. Okay, and this is 3 to the exponent x squared, and we're gonna add 1. So we are adding exponents because the bases are the same. All bases are 3, and we have a multiplication. That's on the left hand side. On the right hand side, what we have is still just that term there, 3 to the exponent negative 3x. So basically we have that x squared is equal to negative 3x, and we continue by doing this. X squared plus 3x is equal to 0. Okay, and we see a common factor of x, so we can take x out, and that will be x plus 3 is equal to 0. This is a product. In order for this to be 0, x must be 0, or x plus 3 must be 0. Okay, so we have x is equal to 0, or x plus 3 is equal to 0, and this leads to x is negative 3, and our problem is solved. Okay, let's look now at the next set of problems. Okay, this set of problems uses a slightly different technique, but we will see that again having similar bases helps. But what works here, the technique we employ, is a factor that we can take out. For example, you see this is 3 to the exponent 2x minus 1, subtract 3 to the exponent 2x. So we have 3 to the exponent 2x appearing twice over. Can we take it out? Then we would have 3 to the exponent 2x multiplied by 3 to the exponent 1. Why? Well, so that when we multiply this by this, we are able to do exponent addition because the bases are the same, and we will have 3 to the exponent 2x plus 1. Then we do our minus sign, and we need a 1 here for this expression to be true. So 3 to the exponent 2x multiplied by 1 will be 3 to the exponent 2x. 18. How can we, okay, but let's keep it as 18. Can we, I was just thinking, can we write it as an exponent, as an expression with a base 3, but that's not necessary just yet. So let's simplify what we have on the left. So this is 3 to the exponent 2x, and we're multiplying it by, this is 3 subtract 1, so that is just 2. Okay, and this is 18 this side, so we have 3 to the exponent 2x, and we divide both sides by 2. When we divide both sides by 2, we realize that this will be equal to 9. 18 divided by 2 is 9. Now 9 is 3 squared, so we have 3 squared. So clearly 2x is equal to 2, and our x is equal to 1, and we get this by dividing by 2 both sides. Okay, let's look at this last problem, and we have an interesting expression. This is a subtraction sign here. Can we group terms that have that 3 to the exponent x in them? So this would be 3 to the exponent x plus 2 added to 5 multiplied by 3 to the exponent x. So multiplication, and on the right remaining is a 42. Again, we see that we can take out 3 to the exponent x, and we would have 3 squared. So that when we multiply this by this term of 3 to the power x by the term 3 squared, we will be able to add exponents and have 3 to the exponent x plus 2. Okay, so this multiplication gives us that first term, and we have our plus sign. What's remaining here is a 5, so we have 3 to the exponent x multiplied by 5 to get what we had there, and we keep the right hand side as 42. This is 3 to the exponent x, and we have 9 plus 5. This is a 9. What is 9 plus 5? A 14. Okay, and 42. 3 to the exponent x will be 42 divided by 14. Well, 42 is 7 multiplied by 6. 14 is 7 multiplied by 2. So you see 7 cancels 7, and you see that this is a 3. So our 3 to the power of x is equal to 3, which is taken to the exponent of 1. Then we can conclude that x is equal to 1. Okay, that is a wrap for this solve for x problems. Thank you.